Assalamualaikum and good morning to all the listener and examiner. Today I will present the report PSM 1. The title is Effect of Biodiesel Production Based on Zinc Chloride Supported Silica Oxide. The supervisor is Dr. Muhammad Aizal bin Muhammad Hussein. So the outline is introduction, problem statement, objective or scope, literature review, methodology, expected outcome, Gantt chart and reference. So first one is introduction. The use of heterogeneous catalyst zinc chloride ZnCl2 on silica oxide SiO2 by impregnation method is proposed to investigate the effect of using this abundance construction material in producing a high quality green biodiesel. This catalyst will be tested in the biodiesel production by conventional transesterification process enhanced with methanol MEOH by using high free fatty acid FFA of waste cooking oil WCO as main feedstock. So next is zinc chloride. I will introduce first the zinc chloride ZnCl2. It is which come in 9 different crystalline form, are colorless or white and very soluble in water, largely used in pharmaceutical and textile. An increase in biodiesel transesterification efficiency has been shown to be due to the high tolerance for free fatty acid and support interaction of zinc and zinc oxide. So next is supported catalyst, which is silica oxide SiO2. Silica is a critical component of sand in various places around the globe. As an additive and anti-caking ingredient in the food sector, silica had gotten a lot of attention as a high potential biodiesel producer due to its high surface area, huge pore volume and heat stability, according to NS Lani 2020. So next is biodiesel B100. Biodiesel is a liquid fuel often referred to as B100 or plain biodiesel. Source of biodiesel feedstock was microbial oil, including microalgae, yeast, fungus and bacteria. Biodiesel is a renewable fuel with no impact on climate change due to its closed carbon cycle. WCO or waste cooking oil is commonly utilized to make biodiesel because of its inexpensive cost and extensive availability. Transesterification is the most convenient method because of its cheap cost and simplicity, according to Rizania 2019. So next, second one is a problem statement. Many limitations to produce biodiesel fuel, such as cost of zinc chloride and silica oxide being quite expensive. The second one, the parameter will be to check if the biodiesel meet the requirement according to the ASTM D6751 standard, and it will require a lot of time. Third one is to check the parameter. The procedure should be repeatedly get an accurate result and require a lot of energy to work on this process. So next, the objective of the report is to prepare and categorize the different percentage weight over weight sample, which are 1%, 2%, 3%, 4% and 5% of the silica oxide mixed with zinc chloride as catalyst. To examine the fuel properties, silica oxide mixed with zinc chloride with different percentage weight over weight. To determine the biodiesel oil produced meet the requirement of a ASTM D6751 standard. So next, research scope. The first one, producing silica oxide and zinc chloride with different weight over weight sample as a biodiesel production feedstock. The second one is converting the zinc chloride ZnCl2 to zinc as a heterogeneous catalyst to mix with silica oxide SiO2. The third one is performing the transesterification process for the sample to produce biodiesel fuel. The fourth one is the biodiesel production must do the required standard preparation of the ASTM D6751 test. So next is literature review. The biodiesel are employed as a renewable energy resource to reduce pollution and concern about fossil fuel supplies in the medium and long term. According to Marimutu Prabhu 2019, biodiesel may be used in combustion ignition engine with few or no modification. The use of varied mix ratio of biodiesel to achieve high certain number and lubricity is also not worth. Zinc chloride or ZnCl2 may be produced either directly or by evaporating the aqueous solution that is formed during various procedures. As a drying agent and flux, it is utilized because it is very deliquescent water or water absorbing, according to Li Wancheng, 2021. According to NS Lani 2020, silica has a high catalytic response and a stable surface in biodiesel synthesis. So next is wet impregnation is used to make the silica according to NS Lani 2020. This make the method then the author use it the best for mixing the mixture of two different substances to produce the catalyst for biodiesel production. Methanol MEOH was used in the transesterification process in the biodiesel production because it is cheap and reactive. Methanol also primarily benefits chemical and physical properties. Next, methanol is also easier to find compared to other alcohol. Next, heterogeneous catalysts such as those developed by HH Madia 2017 minimize processing cost by allowing the catalyst to be separated, recovered and used. Because the saponification site reaction can be avoided, biodiesel may be produced without the requirement for a separate separation step. So next step is methodology. Methodology. We start the catalyst preparation first. We prepare the first 5%, 2%, 3%, 4% and 5% of zinc chloride ZnCl to mix with silica oxide SiO2. The catalyst will undergo the wet impregnation. Wet impregnation is a process we will add the distilled water about 150 ml distilled water. Then the catalyst will undergo the drying process. Next is calcination. Each of the different weight overweight percentage weight overweight the chloride mixed with silica oxide will undergo calcination process. So the temperature for the calcinate is 300, 500 and 700. Then the catalyst will undergo the XRD, X-ray diffraction process. Then it will undergo the acid esterification process to get the free fatty acid less than 5%. Then we check the full properties of the oil, acid value, kinematic viscosity and water content of the oil. Then the catalyst will undergo the transesterification reaction to produce the biodiesel oil. So if the reaction not complete, it will undergo transesterification again until it reaction complete. Using the different weight overweight percentage mixed with zinc chloride mixed with silica oxides. Then the full properties will then the catalyst will undergo the full properties based on ASTM D6751. Then we get the biodiesel which is B100 and the process will end. So next expected outcome, the first one, the heterogeneous catalyst that were used is able to produce the high quality green biodiesel. The second one, the B100 biodiesel that produced will meet the ASTM D6751 standards. Next, third, the zinc chloride mixed with silica oxide will react on transesterification reaction to produce biodiesel. Fourth one, the high yield of biodiesel production must more than 90%. That's the expected outcome of this project. So this is Gantt chart of the PSM1 report. The first week of the March, we need the topic confirmation. Second week is identify the need. Identify the objective, scope, and problem statement. Third and fourth, familiarize with chemistry, substance, and tool to use. The April week 1 to May week 1, literature review preparation. Next is May week 1 to week 4, we develop the biodiesel production methodology. Week 2 to week 4 on May, we report PSM 1 preparation. Then June week 1 is submission of report PSM 1, correction of PSM 1 on week 2 and week 3 of June. Video presentation PSM 1 is on week 3 of the June. Submission of final PSM is week 4 of the June 2022. So next, this is a reference. That's all for the PSM 1 report presentation. Thank you.